Hello dear students, I'm Dr. Moin. Students, in this video we are going to discuss some of the MCQs on fluorescence spectroscopy. And this is part 1 containing total 25 MCQs. And these are going to be very much helpful for you in your upcoming exam. So let's get started. Before starting the video, if you didn't subscribe my channel yet, then subscribe it right now and also press the bell icon so you may get in touch with my upcoming videos. So here's the question number 1. Fluorescence is a result of transition of electron from, let's see the options. A, from singlet ground state to singlet excited state, from lower singlet excited state to singlet ground state. Option C is from triplet excited state to singlet ground state, and option D is from triplet ground state to singlet excited state. So let's see what is the right answer. So right answer is option B, that is fluorescence occur in the result of transition from lower singlet excited state to singlet ground state. Then question number 2. When the average lifetime of the excited electron is of the order of 10⁻⁻12 seconds, it mainly results in, let's see the options. A is fluorescence, B is phosphorescence, C is vibrational relaxation, while D is all of the above. So let's see what happened in this time span. So the right option is the option C, and that is vibrational relaxation. Then question number 3, and this is regarding the instrumentation. So most of the commercial spectrofluorometers use, let's see the options. A is frontal geometry, B is right angle geometry, while C is straight through, and D is all of the above. So let's see what is the right geometry used by most of the commercial spectrofluorometers. So here is the right option, and that is B, that is the use right angle geometry. Then question number 4. Quantum yield of fluorescence is the ratio of intensities of, let's see the options. A is the incident radiation to fluorescent radiation, B fluorescent radiation to incident radiation, C is the absorbed radiation to fluorescent radiation, while D is fluorescent radiation to absorbed radiation. So let's see what is the right option. So quantum yield of fluorescence, actually it is the ratio of intensities of fluorescent radiation to absorbed radiation. So D is the right option here. Question number 5. The spectroscopic technique that is more sensitive. So that is, let's see the options. A is UV visible spectroscopy, B is fluorescence spectroscopy, C is both UV visible and fluorescence, while D, sensitivity is variable according to analyte. So let's see what is the right option. So the more sensitive technique is fluorescence. So option B is the right answer here. Then question number 6. Electron spin is reversed in, let's see the options. A is in fluorescence phenomena, B is in phosphorescence phenomena, C while in IR spectroscopy, while D in NMR spectroscopy. So let's see what is the right option. So right answer is the option B, that is phosphorescence. So during this phenomena, electron spin is reversed. Then question number 7, and it is regarding the interferences in fluorescence spectroscopy. So let's see the statement. Self-absorption of the fluorescence radiation can be decreased by, let's see the options. So A is by filtration, B is dilution, C is the monochromatic radiation, while D is complexation. So self-absorption can be decreased. So let's see the option. So right answer is the option B, by dilution. So by diluting the sample, this interference can be overcome. Question number 8, again from interferences. So resonant broadening is the broadening of the spectral line which is due to, let's see the options. A is the movement of gaseous atoms, B is due to collisions between atoms and other molecules, C is due to collisions between analyte atoms, while D is due to formation of diatoms. So let's see what is the reason of the problem. So right answer is the option C, that is due to collision between analyte atoms. Then question number 9, which of the following is being used as continuous source for fluorimetry? So let's see the options. So A is the deuterium discharge lamp, B is the xenon arc lamp, while C is the mercury vapor lamp, and D is the hollow cathode lamp. So let's see what is the continuous source used in fluorometry. So here is the answer, which is option B, that is xenon arc lamp. Question number 10. Which of the following compounds doesn't fluoresce, mean they don't show the phenomena of fluorescence? So let's see what type of compound they are. So here are the options. A, compounds with multiple conjugated bonds. B, conjugation with electron donating group. So those compounds. Option C is the polycyclic compounds, and option D is non-planar compounds. So let's see which type of compounds don't show the phenomena of fluorescence. So here is the option, and that is the option D, and that is non-planar compounds. So these are the types of compounds which do not show the phenomena of fluorescence. Number 11. Phosphorescence mainly results from, let's see the options. A is internal conversion, B is vibrational relaxation, C is intersystem crossing, while D is all of the above. So phosphorescence actually it results from due to intersystem crossing. So C is the right option here. Number 12. In fluorescence spectroscopy, emission spectra is obtained by keeping, let's see the options. A, excitation wavelength constant, B, by keeping emission wavelength constant, C, by keeping both excitation and emission wavelength constant, D, by keeping both excitation and emission wavelength varying. So let's see what is the right answer. So emission spectra can be obtained in fluorescence spectroscopy by keeping excitation wavelength constant. So A is the right option here. Number 13. fluorescence intensity is reduced by, let's see the options. A, by intersystem crossing. B, due to vibrational relaxation. C, due to conjugation. While D is due to both A and B. So let's see what is the right answer. So fluorescence intensity is reduced actually due to both A and B, that is due to internal system crossing and vibrational relaxation. So D is the right option here. Number 14. Which of the following factors increase fluorescence intensity? So let's see the factors. A is electron withdrawing group. B is the photo decomposition. C is increase in temperature, while D is increase in viscosity. So the factor which actually increases the fluorescence intensity is D, and that is increase in viscosity. Question number 15. Fluorescence quenching is, let's see the options. A, it is the conversion of fluorescence to phosphorescence. B, it is enhancement of fluorescence. C, it is the absence of fluorescence. While D, it is the repression of fluorescence. So let's see what is right about fluorescence quenching. So it is actually option D, that is the repression of fluorescence, mean the suppression of fluorescence is called fluorescence quenching. Question number 16. The selectivity and sensitivity of fluorescence spectroscopy is higher than that of absorption spectroscopy because of all of the followings except. So let's see what is that option. So here are the options. A, fluorescent substance have different lambda max of excitation and emission. B, the rigid molecules can only fluoresce. C, fluorescence intensity depends on the intensity of the incident radiation. While D, every molecule that absorbs in UV region can show fluorescence. So let's see what is the most appropriate option. So that is option D, means every molecule that absorbs in ultraviolet region can show fluorescence. Question number 17. Which of the following are used as sources in fluorimetry? Let's see the options. A is deuterium discharge lamp. B is xenon arc lamp. C is the mercury vapor lamp, while D is both B and C. So let's see what is the right answer. So right answer is the option D, that is both B and C, means both xenon arc lamp and mercury vapor lamp are used as sources in fluorimetry. Number 18. Which detector is used in fluorimetry? Let's see the options. A is photovoltaic cell. B is photomultiplier tubes. C is the phototube, while D is all of above. So let's see what is the right answer. So right answer is option D, means all of above. So photovoltaic cell, photomultiplier tubes and phototubes all are being used as detector in fluorimetry. Question number 19. The purpose of secondary filter in fluorescence spectroscopy is, let's see the options. A, it allows only excitation radiations. B, It allows only emission radiations. C. It allows both excitation and emission radiations. While D. It allows transmitted radiations. So let's see what is the right answer. So right answer is the option B, that is secondary filter allows only emission radiations. Question number 15. Fluorescence quenching is, let's see the options. A. It is the conversion of fluorescence to phosphorescence. B. It is enhancement of fluorescence. C. It is the absence of fluorescence. While D. It is the repression of fluorescence. So let's see what is right about fluorescence quenching. So it is actually option D, that is the repression of. And I know that you have question in your minds that how para substitution increases the fluorescence phenomena in aromatic compounds. So to answer that, here is the next question, and that is question number 21. The increase in fluorescence phenomena in para-substituted aromatic compounds is due to. So let's see the options. A is due to electron donation. B is due to electron withdrawing. C is due to confirmed planarity to ring, while D is due to confirmed rigidity. So let's see what is the right answer. So right answer is the option C, that para substitution actually it confirms the planarity of the ring, which increases the fluorescence phenomena in aromatic compounds. Then number 22. The fluorescence intensity increases with all of the following except. So let's see the options. A is rigidity, B is planarity, C is the number of rings, while D is dissolved oxygen. So let's see which one is not responsible for increase in the fluorescence intensity. So that is option D, means dissolved oxygen. Then question number 23. The fluorescence intensity depends on all of the following except. Let's see the options. A is the concentration, B is the polarity, C is the path length, while D is the intensity of incident radiation. So let's see what is the right answer. So right answer is option B, that is polarity. So fluorescence intensity doesn't depend on polarity of the sample. Question number 24. Heavy atom effect is not more with, let's see the options. A is fluorine, B is chlorine, C is bromine, and D all have equal effect and it depends on valency. So let's see what is the right option. So right answer is option A, that is fluorine. And then last question of this current video, and that is question number 25. The primary filter is placed in between. Let's see the options. A, so that is kept between source and cell. B, between cell and detector. C, between source and detector, while D is placed anywhere. So let's see what is the right answer. So right answer is option A, that is primary filter is placed in between source and cell. So dear students, this was all about current video, but still there are a large number of videos in the pipeline. So to get them in touch with all of those videos, you need to subscribe my channel. So thanks for watching. Thank you very much.